chart. So go ahead and get out your trig chart. If you need one, as I'm walking around, wave at me and I'll give you a trig chart. Okay? If you already have one, you'll probably want to use the one that you have.
I'm just gonna get another one.
There's lots of things that you probably wrote on there. Have it, Stephanie? I saw that lady.
Yeah.
John, need it?
I may send it.
You were?
I'll leave it here.
Okay.
Don't need it, put it over there on the.
I see.
Things are organized.
Got it all warm and
Here you go, iPad. She's got it. Yes, yes, and there we go. All right. So, what we are talking about today, class, something we've mentioned before, but we're going to hit again, and that is inverse trig functions.
You're very close to me.
Both today and tomorrow we're wrapping up with inverse trig functions. Just a little bit of last minute details. It's also kind of a good, nice closeout review that might even discuss some of the things we dealt with our graphing, all that stuff all combined. Okay? So there are 3 items that we need to compare and contrast. 3 functions here. Okay? So I'll put them over here on this board here. Y equals sine of x. Y equals cosecant of x. And y equals inverse sine of x. We've talked about these verbally, but it's kind of good for us to get a big picture view. I don't think there's, for this first part, anything new that I'm going to be telling you. But when we do some of our problems today, we're going to have something like, what's the sine of the cosecant of the inverse sine of pi over 2?
Oh,
And we're like, what in the world? So we're going to be mixing and matching and having functions of functions, and what's the inverse sine of the inverse cosecant of, and so we really need to be rock solid on what each one of these 3 things mean, okay? In this case, in all 3 of them, there's an input and an output. And we're just going to be dealing with sine, cosecant, and inverse sine. But at the very end, I'm going to say, and also the similar process with cosine and tangent, similar process with secant, cotangent, so on and so forth. Okay? So, on the y equals sine of x, normally, this is how it might be, but we might also see it written as y equals sine of theta. Same thing with the cosecant. Y equals cosecant of theta. That should make it a little bit easier for us to recognize what type of a thing is the input. Anybody want to give me an answer to that? What type of thing is the input? It's an angle. And we normally measure that angle in degrees or radians. And that's the same thing for cosecant. That input is an angle in degrees or radians. What's y? What kind of a thing is that? If I say y equals the sine of theta, so like y equals the sine of 45 degrees. It is a ratio. I love that word. Thank you. It's the ratio. Let's go back to our right triangle trig. If it's an actual right triangle, it's the ratio of what over what? In a right triangle. Opposite over hypotenuse. That's right. Or if it's if it's dealing with something maybe beyond a right triangle, maybe say our angle theta terminates here in the second quadrant. What's another? It's not the ratio of the opposite over hypotenuse, it's the ratio of what over what? Remember the alternate, we called it, I think, the circular function definition. What do you got there, Ashlyn? Y over R. And just to remind everyone what y is and what r is, y is the y coordinate on the terminal side. That's this guy right here. And r is the length of the terminal side. Okay, let's discuss those same things over here with cosecant. If y equals cosecant theta, that is also a ratio. Would somebody new tell me what is the cosecant of theta give you the ratio of? R over y. Also hypotenuse over opposite. So if we wanted to, we could write that's the length of the terminal side divided by the y coordinate of the terminal side. All right, well that's all well and good. But what about this guy? Y equals inverse sine of x. Let me help you out here before we go deeper here. Sometimes, instead of saying y equals inverse sine of x, we would write theta equals inverse sine of x. So somebody tell me, what type of a thing is the x? It's a ratio. It's the ratio of what over what? For inverse sine. Nope. Yeah, it's R. Nope, it's not over. It's not over y. It's the same thing as that guy over there, sine, but just everything switched. Yeah. It's a ratio of the opposite over the hypotenuse, or the y over the r. It's just literally the inverse. We switch the domain and the range, so to speak. Switch the y and the x, kind of. Okay? Theta, right here, is the angle in radians or degrees. So for instance, I could say that sine of pi over 3 equals, let's go ahead and look at our unit circle. I'm looking at the angle, pi over 3, and I'm going to spit out, no, not 60. Root 3 over 2. So this one says the input is the angle, the output is the ratio. So you give me an angle, I'm going to look at the angle, and then I'm going to tell you what the ratio is that corresponds to that. Okay? So I'm going to look at this and tell you that. Let's do another one just for fun. What about the sine of, oh, I don't know, 3 pi over 4? So we remember, look at 3 pi over 4 on the radians, and you tell me what's the y coordinate that corresponds to that, Mason?
The square root of 2 over 2.
I agree. Any questions on that? This is old news. This is also kind of old news, but by the way, I mostly have this middle guy here just as a reminder that it's the flipped one. This is the reciprocal ones. Okay? So here, the equivalent sort of backwards problem would be inverse sine of root 3 over 2 equals so what I'm going to do is I'm going to look at root 3 over 2 on the y values, and I'm going to find the angle, and that's the answer that's going to be over here. So Nick, look for root 3 over 2 on those y values. Got them? Look for root 3 over 2 on those y values on your unit circle, and tell me what are the angles in radians?
2 pi over 3 and pi over 3.
Ooh, there's two of them, pi over 3 and 2 pi over 3. That's interesting. We've got two answers. I don't like that. I like just one. You know what I'm talking about? I do this. I want one answer. I wonder if that's true for something else. What if we would do inverse sine of root 2 over 2? John? Look at root 2 over 2, look at all your y values and find where you've got root 2 over 2, and you tell me the angle. Have you found root 2 over 2? Look at the y values, look at around that unit circle,
Yeah.
and you see where they have all a bunch of ordered pairs, right? Do you see root 2 over 2 listed in any of those ordered pairs? In the y position.
Pi over 4.
Okay?
Well, there's another one.
You tell me that one.
3 pi over 4.
Yeah. Yeah, I know you didn't want to disappoint me, but you did not disappoint me by telling me those two. My disappointment is not in you, Sean. My disappointment is with the unit circle, that it's giving us two answers. Okay? You did good. Good job. This is 100% correct. That you do get that the inverse sine of root 2 over 2, it occurs at pi over 4 and 3 pi over 4. Although technically, I would argue that it occurs more than just those times. It occurs at pi over 4, which happens to be 45 degrees. It occurs at 3 pi over 4, but it also occurs at right there, same spot, right? Coterminal angle, and around once, around twice. First quadrant, 45 degrees. You see what I'm saying? We actually have technically an unlimited number of possible answers. But mathematicians said, okay, look, we know you can go around and around. Let's at least give something in, like, just within one rotation, okay? But even if you're looking at one rotation, you still have the dilemma that I get two possible answers here, and I get two possible answers here, and you get two possible answers for pretty much any of those values. And so they need to make a decision, which of these are we going to accept, okay? And if you type in inverse sine root 3 over 2 on your calculator and hit enter, it's only going to give you one of these two. It's not going to give you two answers. Remember the good old vertical line test? Whether or not it's a function? Did y'all ever do that where it's like, you had something where it kind of like functioned like you could pass the pencil through it horizontally? Vertical line test was, I give you one x value, you better give me one y value. You give me two y values?
How dare you?
That's right, how dare you? Not a function, okay? So mathematicians, they rigged this, so they said, okay, we're going to make it a function because we're only going to give you one of the answers. Is that great? That's yep. So the question is, which one of these two are you going to give? And here, which one of these two are you going to give? Okay? So I'll tell you how they made that decision. So here's the question. I'll write it very clearly. The question is, which answer, or maybe you should say, which angle is the correct answer to y equals inverse sine of root 3 over 2. And the answer is whichever one is in the fourth quadrant or in the first quadrant. Inverse sine only gives first quadrant answers and fourth quadrant answers. Okay? So, out of these two, pi over 3 and 2 pi over 3, which one of those is in the first quadrant? Pi over 3. And your correct answer is pi over 3. Let's grab a calculator and check it out. Make sure your calculator is in radian mode. And let's do inverse sine of the square root of 3 divided by 2. Calculator says 1.047. That's mine says. Does yours say something similar? Now, let's check. What is pi divided by 3? I get 1.047197551.
So we're doing inverse sine of,
Inverse sine of root 3 over 2.
it's in radian, right?
Yes.
It keeps saying domain. Yeah, mine keeps
Yeah.
Make sure
going
your
with
square.
errors.
Okay, make sure your square root ends properly. That looks good. Now hit enter. Try it again.
Not
Oh.
showing your.
Oh, there we go. I don't know what the problem was before,
Because you don't have an
but
outline for you on this one.
Okay,
I
that's
can
also
do it.
wrong because
The
you need you gotta
Probably
close the
not,
parentheses
but
after the
I'll
three.
Where?
Nia's
I
got it.
just realized what I did wrong.
I got it now.
Square root of 3. Close that parentheses. Divide by 2. Close that other parentheses. There we go.
Yeah.
Ding ding ding. She's got it. She's got it. He's got it. Calculator cheers.
Oh.
Yeah. So 2 pi over 3 doesn't matter. We good? We
I'm
good?
taking the key.
Janie, yes?
Yeah, I got it.
Alright. It's all about closing that parentheses after the square root symbol if you don't have one of these nice little blue calculators. Or these nice big blue calculators. Okay. Okay. Now, just out of curiosity, if I were to tell you I only want angles between quadrant 1 or in quadrant 1 and quadrant 4, give me some, let's just give me in degrees just to make it simple. How would you describe that answer in degrees? So the answer is whichever from quadrant 1 quadrant 4. So that means angles in degrees. How would you describe from quadrant 1 and quadrant 4 degrees? Go ahead, John, out loud.
0 to 90 and 270 to 360.
0 degrees, 90 degrees, and 270 degrees to 360 degrees. Would y'all agree with that statement?
Mm-hmm.
That's quadrant 1 and that's quadrant 4. Okay. Good. Now I want I don't want an and statement. I want to make this, I want to simplify this. I want one number to another number.
Negative 90 to
Negative 90 to positive 90. Negative 90 to positive 90. Now I want it in radians. I said now I want it in radians. What's 90 degrees in radians? Okay. So from negative pi over 2 to positive pi over 2. And that's the most official answer. I'm not going to play any more games on that one. Okay? So, what is the correct answer? The answer is, you could say the first, if you're doing an inverse sine, the calculator is going to spit out an answer between negative pi over 2 and positive pi over 2. Okay? Let's do one or two more here just to make sure that we're rock solid on this. Because I feel like we've done inverse sine stuff, but we're not really good on it. You know what I mean? Let's go ahead and try some more. All right. So what about inverse sine of negative root 2 over 2? Haley, you're going to look for negative root 2 over 2 on the y values, right? So I'm going to say look at y values, and I want you to find the angles. Okay? So just go ahead, if you'd rather give them in degrees, we could do that, or you give them in radians. Radians, I guess, is fine. So Haley, give me one of those angles.
Oh, okay. I was really confused, sorry.
Give me one of the angles where we would have a y value of negative root 2 over 2.
5 pi over 4.
That's great. 5 pi over 4. Somebody else? 7 pi over 4. Would all of you agree with this? Now, which of those two do we like? We like the 7 pi over 4. Why? It's in fourth quadrant. Okay, so goodbye 5 pi over 4. We do like you. However, 7 pi over 4 is literally 315 degrees, right? Okay, also known as 315 degrees. Does that fit my negative 90 degrees to positive 90 degrees criteria? No, it doesn't. Okay, so what is another name for 315 degrees that is like a coterminal angle that happens to be between negative 90 and positive 90? Not negative 60.
Negative 45.
Negative 45.
Oh.
Negative 45 degrees. There we go. That's in between negative 90 and positive 90. So now let's convert that back to radians. That would be, so 45 degrees is pi over 4. So our correct answer is negative pi over 4 radians. So tricky. Let's see if we're right. Calculators. Inverse sine of negative square root of 2 divided by 2. Inverse sine negative root 2 over 2. Calculator says negative 0.7853. Would y'all agree with that?
Yes.
Now what is negative pi over 4? Oh, it is. Okay, so we are on the right track. Everybody feeling pretty good on this? Okay. Some of this is actually even harder than your homework stuff. I don't know why I'm even doing these hard things. Okay. All right. So I'm feeling good about that. What are the other functions that fit into this category? There's sine, there's also cosine, and there's also tangent. The reciprocal identities, or the reciprocal functions, there's cosecant, secant, cotangent. With inverse sine, there's also inverse cosine, inverse tangent. I mean, there's actually also inverse cosecant, inverse secant, and inverse cotangent. We're going to be focusing in, though, on the inverse cosine and inverse tangent. So, looking at the inverse here, inverse sine, and we got two angles, all right? That same phenomenon is going to occur with inverse cosine and with inverse tangent, okay? And by the way, just to bring back painful memories, the problem with that inverse sine giving two answers it's kind of fuzzy which one it is, right? You might even say it's ambiguous. All right? And this is the source of the ambiguous case of the law of sines. Because you were doing the inverse sign in order to find the angle. Just to bring back some painful memories. All right? Let's deal with an inverse cosine or two, shall we? What if I said, what is the inverse cosine of 1/2? Okay, fine, we'll do easy. So what does that mean? Now I'm going to label this here because everybody forgets after they do their notes. All right? So that means look at the x values of 1/2 and find the angles. So somebody picked on you up here. Narabi, look at your trig chart. Find one angle who has an x value of 1/2. I agree, pi over 3. But there's another one equal to it. 5 pi over 3. Oh, she's going 2 for 1 here. All right. So, oh, I know. How do I choose?
If they're in the first or the
If they're in the first or the fourth quadrant, right?
both in the first.
Sorry, I'm just like, today is the day of, think you get it, then there's a roadblock. Think you get it, there's a roadblock. That's right. So yeah, first and fourth quadrant. But wait a second, those are both, this one's in the first quadrant and this one's in the fourth quadrant, right?
Yeah.
So how do you choose? With cosine, the mathematician said, yeah, that's kind of an issue. Let's let it, for cosine, we declare that inverse cosine shall only contain first and second quadrant answers.
Oh.
Okay? So, inverse cosine gives only quadrant 1 and quadrant 2 answers. I know it's kind of annoying, but they threw us a lifeline here. In degrees, that would be between 0 degrees and 180 degrees. Or in radians, that's just going to be from 0 to pi radians. So none of that rigmarole with inverse, like negative pi over 2 to positive pi over 2, like yuck, nice sine, inverse sine. With cosine, it's just going to be your straight first or second quadrant answer. Now we have an option. So what is, which of those two is in the first or second quadrant, class? Pi over 3. Goodbye, pi over 3. According to us, I type in inverse cosine 1/2. Calculator should give me an answer equivalent to pi over 3. Let's see if it does. Inverse cosine 1/2. I got 1.0471. Y'all get that?
Yes.
I type in pi divided by 3, 1.04719755.
Well.
I'm convinced. Let's do one more, shall we? Inverse cosine of negative root 3 over 2. Janie, what this means is look at x values of negative root 3 over 2, and you tell me, or you find, the angles. Give me one angle there,
Do
Janie.
you want them in degrees or radian?
Radians, por favor.
Okay, 5 pi over 6 and 7 pi over 6?
I agree. However, which of those is in the first or second quadrant?
5 pi over 6
You are correct. See, I think we're getting pretty good at this. You just have to remember the cosine is in the first and second quadrant. You can use your calculator to check that. Okay, but what about tangent? You want to know which quadrant tangent cares about?
Third.
It's actually the same as sine.
Oh.
All right.
That's gonna be none
So tangent, inverse tangent gives only quadrant 1 and quadrant 4 answers. That is from negative pi over 2 up to positive pi over 2. Now we may need to have a little fun with this because a lot of you, I just gave you a new copy of your trig chart, and you don't have tangent written all around on the outside. Does anybody have tangent written around on the outside of theirs?
I have some. Wait, what do you mean?
Like, let's go forwards. Just give me an example of what I'm talking about. If I said what's the sine of pi over 6, you can get that no problem. Because sine means look for the y value. Pi over 6, oh, it's 1/2. You got it. If I said what's the cosine pi over 6, you could say root 3 over 2, right?
Oh, I know what you're talking about now.
But if I said what's the tangent of pi over 6, oh no, there's see what I'm saying? There's nothing there.
Fractions on fractions.
Yeah. So let's go ahead and fill out some of these just to get ourselves remembering what these things are. Tangent of pi over 6 is fractions of fractions. That's going to be 1/2 over root 3 over 2. So that's 1/2 times 2 over root 3. Does anybody have it just listed already? It's 1 over root 3, which is, y'all have that root 3 over 3? Well, actually, you said you had it written down.
I have like tangent of 90 degrees is undefined. That's
Oh,
right. I have
okay.
those things.
Gotcha. Alright. Tangent pi over 6. Let's check it to make sure we're right here. Ladies, you type in tangent pi over 6. Guys, you type in root 3 over 3. And then everybody shout out your answer at the same time.
Oh. We need to go back to the.
No.
No.
We're in reading.
Yeah, I did.
Alright, on the count of 3, shout out your answer. 1, 2, 3. No, it should be 0.5.
0.57.
Yeah.
0.577. Boys and girls agree? At least on something.
Yeah.
Okay, there we go. Alright. Tangent of pi over 4. We could probably do this one in our head. It's the y value, root 2 over 2, divided by the x value, root 2 over 2. So anybody, what is root 2 over 2 divided by root 2 over 2? You are correct. Tangent pi over 3 is root 3 over 2 divided by 1/2. So it's going to be root 3 over 2 times 2 over 1. So that's just going to be good old root 3. Tangent of 90. Let's try tangent pi over 2. 1 over 0, undefined. I think we noticed the pattern, which is why you didn't have it written down in the other quadrants. Let's check it real quick. Tangent of 2 pi over 3 is the y value, so root 3 over 2 divided by negative 1/2. Which one of those does that look like? Root 3 over 2, yeah, looks like this one right down here. Do you see that? It's going to be negative root 3. Tangent 3 pi over 4, negative 1. Tangent 5 pi over 6, negative root 3 over 3. go ahead and, as I'm walking around here, fill out the rest of that unit circle there for me, will you? For your tangents, just kind of stick your. I just kind of write them out on the outer edge. Where we want, so the root 3 over 3 and a 1 and the root 3. You know what I'm talking about? So for instance, if I said, what's the sine, you know right away to look for the y value. If I said cosine, I know the and so, but there's no indication here that you can very quickly just tell what the tangent is, which is why I would write it as a little side number out here, right? Root 3 over 3, 1. You see what I'm saying? Yeah, that's how I would. You know what I'm talking about?
Yeah,
Like,
and
right there, I would put root 3 over 3. And right there, I would put 1. And right there. You know what I mean? So, I've got another
but
concept.
it's easy for you to solve it, so.
Okay, yeah, all right, well, that's fine too.
Wait, how do you do the other ones?
She's got it.
Like sine. Yeah, that's one. Try to do the other one.
No, you had.
I know what it is.
Just making sure.
Sure. Well, I know, but you need an expert teacher. I'm building. Yeah, I know. Okay. Some of this might bleed over till tomorrow. All right, here we go, class. So, this is a problem that is the beginnings of something that you might see on your homework. So, if this says inverse tangent of root 3, looking at your trig chart, what are the options? There should be at least two options that you have for root 3. Anybody?
Wait, what did you say? Sorry.
If the question was find the inverse tangent of the square root of 3, okay? Then what you're going to do is you're going to look on, you're going to look at ratios that show root 3, and I want you to find the angle. That's what inverse functions mean. Look for the look at the ratios and give me the angle. So, what angles are present there that match this situation? Anybody? Say again? I hear pi over 3, as well as, was it 7 pi over 3 or 4 pi over 3?
4 pi over 3.
4 pi over 3 is the correct answer for the is the correct other option. Because in that third quadrant down there, they're both negative, and a negative over negative cancels out. All right.
I'm just going around.
But the answer is going to be the first quadrant or the fourth quadrant option, which means
I'm just going
pi over 3.
Okay.
All right. Oh, here we go. I'm changing this one up. What if he said, John? What's the inverse tangent of -1? So somebody tell me, what are my options here? I've got 3 pi over 4 and 7 pi over 4. Would y'all agree with that? Those are your two possibilities. Those are the angles whose ratio would give you -1. So once again, I look for the ratio of -1, and I over here put the angles. Now, which one of those is the first quadrant or fourth quadrant answer? 7 pi over 4 is the fourth quadrant answer, but that's not my official final answer, okay? Because remember, that's not between -90 and +90, or negative pi over 2 and positive pi over 2. And since I'm in the fourth quadrant, I'm going to need to have some sort of negative answer there. So, well, 7 pi over 4, that's 45 degrees below, right? So it'd be negative pi over 4 is my official answer. Don't believe me? Check it out. Try inverse tangent of -1. You should get -0.785398. Then type in negative pi over 4, and you'll find out it's exactly the same thing. Okay? So, a lot of theory, a lot of building stuff, but I feel like we should be pretty rock solid on this stuff now. And we'll be ready to solve some problems tomorrow. Today, class, we talked about the trig functions, a little bit about the reciprocals, just enough, but then also the inverse trig function. The big thing is the inverse trig functions, and if I give you a ratio, then you're going to give me
An angle.
an angle. Okay, all right.
I had to think, I was like, wait.
I'll take it. You killed it.